Good morning, everyone. Welcome to this segment. So, those of us online, you're equally welcome. So, like I said, capital budgeting, or what they call capital investment analysis, under risks and uncertainty. The last one we did was under certainty. When something is certain, that means you are sure. That means you are convinced that something positive will come out. But for this one, risks and uncertainty. When they say a business has a risk, means there is a danger. There is a possibility of loss. That means there is something that will affect somebody. It's not managed properly. I would say uncertainty, it means there's doubt. It means something somewhere could affect something. So there is because there is risk and uncertainty, we need to evaluate our projects to see how we can remove risks. It does not have too much risk, and manage the one that has less risk so that we can evaluate something. And as far as this particular time, there are three methods, only two. One is probability-based approach, and one is non-probability-based approach. Today we are going to look at the probability. So there is nothing here. We have talked about it, this danger. This one, there is a doubt. So when all these things are there, what do we do? There are two methods, like I said. One is probability. You know, probability can mean statistics, I mean. That means statistical method, or probability-based method, or non-statistical method. But we say probability-based method. And then under this method, we'll be talking about one, expected value. Two, we'll be talking about standard deviation. I know that when you talk about standard deviation, there is variance in it. You cannot get standard deviation without a variance. Another one is what we call what we call COB, but let me write it full. Coefficients of variance. Coefficient of variance. And it's okay for that part. Then the second part is non-probability based method or approach, under this, we could be talking about risk adjusted, MPV, B, coefficients, no, certainty, efficiency, approach, that is sensitivity, approach. There are other ones, but at least for this kind of class, this is what we need to understand the stimulant, but these are what you expected to understand. We're going to look at that test, and that test will take our time for today. That second, probably some other time, where we'll have that time. That first one is just simple calculation. It may look very difficult, but it's not if your mind is there. In short, in the simple language, this is number one. This one is all about your knowledge of statistics. Those things, how to find mean, mode, variance, standard deviation, and so on, mean deviation, and so on. But the idea we apply here will be similar, but we will follow a particular pattern and see how it works. That's also how to know which project to take and the one not to take. I'll take 3 questions. The first one is short, second one is short, the third one is lengthy. I believe we should be able to finish that 3, show you that this part number 1 is over. And we'll be able to show you your past question, which you will see, and you should be able to solve it after my 3 examples, except you don't want to attempt, but you should be able to handle that at the end of the day. Any questions? Those of us online, I hope you are following.
Yes, we are.
Good. So we'll take, I write this on the board so that we can see it before it involves calculation. So number 1 for today, the question says the cash flow. There's still cash flow matter in it. The cash flow and probability. Probability estimates. Probability estimates for a 1 year. You can see this one is 1 year, we can see 2 years, we can see 3 years. But this one was starting gradually with 1 year projects. 1 year projects as shown below. The question says calculate the expected value. Expected value of cash flow. B, expected value of MPV. We all know what is MPV, Abi. I don't think there's anybody that does not know what is MPV. But in case there are still persons, is the net present value. Initial projects, outlay. We all know project outlay, Abi. That was the minus, Abi. Let's say this 8,500. And the the discount rates, which I believe is not new to us. So we'll have the question like this. Sorry, let me put here a seal so that we'll use the question once and for all. Standard deviation. Maybe G here. COV. You agree with COV? COV, Abi? See about board. I be this. Have you seen it now? I don't want to manage that part. So let's just do like this. Okay. So this is our cash flow. This is 13,000. This is 11,000. This is 10,000. This is our probability. I'm emanating from this particular question. Probability, you all know, it ranges from 0 to 1, Abi? From 0 to 1, that's probability. Probability that tomorrow will be Sunday is 1. Because whether you like it or not, tomorrow must be Sunday. That's what causes it. And probability that tomorrow will be Monday is 0. Because there's no way tomorrow will be what? Monday. Even if you wish, Abi, it can't come to pass. So when it's going to be possible, it's 1. When it's not going to happen, it's what? 0. So probability ranges from 0 to what? 1. So we move 0.3, and this is 0.2. That's the question. Is that?
If the initial project outlay as they are discounted.
Okay, it's already there. So this one is expected value of the NPV. C, standard what? Deviation. D, coefficient of variance. If the initial project outlay is what? 8.5. And the discount rate is what? 12%. This was the project, a 1-year project. So with that small one, we'll just yes, I can hear you.
Sorry, I didn't get that. That's the COV. What is it?
Coefficient of variance. Coefficient of variance.
Okay.
Is that okay?
Yes.
So we're looking at 4 things here. Expected value of cash flow, expected value of NPV, standard deviation, coefficient of variance. And why this one is coming in is because of this NPV. That's why this amount is coming in. If there's not expected value of NPV, we won't have. We all know that NPV is always minus CORB. That's what that one is there. So can I clean this? Good. Just one matter is to pay attention, look at things properly, and the answer will be as easy as it ought to be. There's 13,000. This one is 11,000. And this is 10,000. There's our probability. I've written PI. And this one could be CI. In this case, we have 0.5. And this is 0.3. This is 0.2. Start like this. We'll go this way. But let's go at probability so that they can see. First of all, I will go on with AI. And this one, we all know is Naira. So, yeah. Now, for us to find expected value, which is A, is going to be CI times what? CI is a very simple multiplication, which I believe your calculator is working now. This is our cash flow. We want to get expected back. And how to do that? Multiply by the probability. If you have done statistical, we normally multiply with the x, the variable, use the variable, times the frequency. So this probability is serving as our frequency. We're not going to divide because it's already fraction or decimal. Whatever we get will be our expected. Oh yeah. 6,500, 3,003, and 2,000. We add everything together. That would be our expected value. What do you have? 11. And that is the end of that first part. We have just got to A. Expected value of the cash flow. Is it clear? Expected value of the cash flow is not that difficult. It's just to use C to multiply that. So in a simple language, let me write A. Expected value of cash flow is 11,800. That one is gone. The next one is D. D. That is the expected value of what? We all know this is our value of it. It's going to be, I hope they have not forgotten, all over 1 plus R of it. What's our R now? So it's going to be 1.12 of it. We all agree. Minus what? CO. So somebody, because it's just 1 year. Raised to power 1, does it change anything here? So our result. Any question? So this is what I got. 105.
Sorry, I'm just joining in. How did you get the 1.12?
Okay, there's a discount factor on the board, which is 12%, and 12% means 0.12. And our formula hasn't changed. It's always CF. The formula hasn't changed, is it? Minus what? CO. This is the normal formula for MPV, have it? But because it's estimated, expected value, this is our expected value. That's why MPV is attached to it. Expected value of MPV will be this expected value. All of our discount factor, we are discounting this a bit, and you know that discount factor is to divide. If it is compounded, we multiply, but we are not compounding here, we are discounting. So this value, we find the present value, which is by discounting it. And by the time we subtract the cost outlay, we now have net present value from what? Expected value. So you say this 10 what? 10,525. Okay, 5 here, Abby. Point what? And this 8,000 what? And the result? 2035 point what? So our expected value MPV is possible. We should go on with this project. Accepted?
Sorry.
We have just answered A. Yes, I can hear you. Go ahead.
The 1.12. How did you get it? I think I missed.
It's on the board now. Discount rate is 12%. Have you done MPV before?
Mm-hmm.
Have you?
Yes.
If you have done MPV, we normally use discount rate, have you? And that the formula here is 1 plus R raised to power n. Our n here is just 1 year, so that's raised to power 1. We'll see that way we'll have more. Is it clear?
Clear.
We have just gotten A. We have gotten what? B. Our formula hasn't changed. This is the cash flow at time 1. It's only 1 year here, right? That means this is 1. And which is this one? Is this still 1? And our R is 12%, which you know is 0.12. And 1 plus 0.12 is 1.1. Divide this and subtract our capital out. Is it clear? Remember this expected value of the MPV of the cash flow. This is the formula for expected value. Just multiply. I don't think multiply is a problem for us. Our calculator is doing well. Eh? Yes, we must use this. This times this. If you don't like that, there's nothing wrong. You can say this times this. Hello. This times this plus this times this plus this, and you get it. So go ahead. You know MPV already. You know our MPV is always cash flow over the discounting factor. But because this value is expected value, so we're looking for expected value of the MPV. So this one is the matter over this minus what? The cost outlay or the project cost. This is the project cost. It's 5. Okay, go ahead. Okay, if you want to be like that. Oh, you're getting different. Okay, there's nothing wrong. You can, okay, just divide this straight now. There's no need putting minus 1, just direct. Oh, yeah, now you see the same to your present. Times 11. Is it not the same? Okay. Take it to there. Not the best too much. This is easy. This is just a project for 1 year. We'll have other ones that have more than 1 year. We'll see that. No, you do understand. We'll get there gradually today. As far as we are getting it faster, we'll get there. This is how it must be. But anyhow you like it, do it. I've shown you 2 methods. The last time we met, we told you about this, that it will be inverse. Sometimes you want to use your calculator. But this one is not that much. It's just raised to power 1. But don't worry, we'll get there. Oh yeah, the next thing is what? C and what? D. Oh yeah, C board. This is my expected value. And in simple language, this expected value is what we call mean in statistics. Mean. And when you get a mean, you get a deviation. Deviation means this is the variable. This is the real variable. The variable, which is always x, for you to get deviation will be x minus what? Mean, Abi? That is the formula for deviation. But in this case, our mean here is what? Expected value. These x are 1, 2, 3. Are you with me? This is called deviation. And this deviation will also be squared and multiplied. But before we get deviation, so it will be a little bit easier. So here will now be C, I have it, which is this, minus E what? V. We'll have another one, CI minus EV, all what? Times what? I hope you are seeing the formula. Where are we getting to? We want to get what? Is it clear? Any questions? So, this is 13,000 minus what? What do we have? The formula matters. 1, 2, good. Now, okay, maybe we'll get this. I did not have it. Good. Minus what? It's also minus, Abby. This one come minus 1/8, Abby. Any question with that? Because of that minus sign, that's how we square. So that the minus sign will disappear. So what you're going to do for me now, you square this, multiply by this, square this, multiply by this, square this, multiply by this, so that we can fill in this column. 720,000. Like this. Next. 192,000. Next. $648,000. Like this, Abby. I hope you multiply like this. Wait, I want to understand. You square this, Abby. I multiply the 1.5. Is that what you have? Okay. Square this, multiply by this. Is that correct? Square this also, multiply by this. Okay. Add everything together for us. What do you have? 1 million. 1560. Like this, Abby. That value I got is the variance. It's called variance. And that's the symbol for variance. That's what I just got now. Variance of the project. Then I'll be able to get standard deviation. Standard deviation is the square root of variance. Is that okay? That means if I square variance, if I square standard deviation, I'll get variance. If I find the square root of variance, I'll get standard deviation. I hope that's clear. Who is not clear with that simple calculation? It's simple. I didn't hear you.
So that's CI and CP there. Because for our standard deviation.
No, where? This one. This variance. Which one? C? No. We are looking for standard one. We have not got it. This one is just deviation. It's not the standard. Is that okay? For us to get standard, which is C, standard deviation of the project will be the square root of variance. And what's our variance? 156,000. And somebody find the square root? 1,249. And that's our answer for that. Is it clear? You said? No, this one is expected value. Can have naira. But standard deviation will not bother about naira. We'll just leave the bar. But if you still want to put naira, because we're talking about cash, there's nothing wrong. Let's still put it for you. It's nothing wrong. Because we're talking about cash flow, which is money. Do you know any people before? You know how to calculate some people. No, it's the same. This is our expected value. We're looking for expected value of the MP. So it's going to be this. Over our 1 plus R, minus the cost RP, which is this. That one that has minus cost of the project. You remember? Cost of project is always minus now, and that's what we're subtracting. Minus 0, which is the cost of project. So that makes it net. But because this value came from expected value, that's why it's expected value of MP. Is that okay? Any questions? The last one, so that we don't waste our time on. This is G. This one is very easy. It's always standard what? Standard deviation over what? Good. So we have 1, 2, 4, 9, all over 11, 800. So what do we have? CO 0.1. That is 10%, but we'll leave it as 0.1. It's okay like that. So that's the end of question 1. And I believe if you understand question 1, question 2 is a short one, you understand.
What matter just to know about this? Not something very. So what matter is just practice. That means perfection, not something so difficult. Okay, those of us online, are you online?
Yes.
Remember, it's just a project, the 1 year project.
Hello, hello. Hello, can you hear me?
Can't hear you now.
Hello.
It's coming.
Okay, thank you.
What's the name again?
Ask your
Okay, good morning, sir. Can you hear me?
ask your question.
Okay, I wanted to ask that what is the significance of this COV to project? Let us say we are comparing 2 projects now. What's the significance of the what's the significance of this 0.1 to the
Mr.
project
V,
we have.
if you connected, can you hear them?
Hello?
Hello, can you hear me?
Hello? Oh, it's disconnected. Consider the following. Two projects. Those of us online question. Oh yeah, ask so you can repeat the question. Two projects that following two projects that have the following have the following standard deviation and expected value of cash flows in year one, comma, calculates the coefficients of variation and identify the riskier projects. These projects A, these projects B, this standard deviation this one 5,800. Second one 8,500 naira. Expected value is 12,000 naira. This one is 15,000. Not to waste our time, everybody can calculate coefficient of variance. Am I correct? For project A,
Yes, sir.
and we quickly do that. It's not everything we are wasting our time. Solve project A, calculate the coefficient of variance. Project B, calculate. Write it down. No. Write it down. I'm not writing. Don't write it down. Let's know. Because we're not solving much about this. Don't write it down. So that when I need to work on it. Calculate coefficient of variance for project A, coefficient of variance for project what? B. If I cannot calculate that, that means all we are doing, we are not following. What's our answer? First line is 0.1. Write the two decimals. I want two decimal. 0.2 decimal. 483, Abby. No, we don't need percent. It's always 0.1. It's a choice. Because, for instance, now, 0.2 is something that's 20%. Whether you put it in. No. Whether you put it in percentage or you leave it as 1, it's still the same thing. So it's a choice. For instance, this is 0.1, Abby. It's something as 10%, Abby. Whether I write 10% or not, this means 10%. 10% means 10 over what? The choice is yours.
Yeah, but what you say that since the lecturer says
No,
you can put it there, you can put it like that. Yes.
This is calculation. Nobody's monopoly of knowledge. Are you following? So that you put 0.1 and you did not put 10%, will give you 0. Talk now, because in the who, if that matter, 0.1 is something as 10%. The choice is yours. You want to move further to 10%, fine. You want to leave it at 0.1, you are still in order. Nobody's monopoly of knowledge. So leave that one. So the choice
But it's advisable if your lecturer says to put it that way, put it the way they
is a choice.
Yeah. No, to them it's not a choice.
Wait, listen.
Because the person that is teaching this is the way I want.
And Gibson, Gideon, Mr. Gideon. Hello, look at this side. Hello, look at this side. When we are marking, are you following?
Yes.
There's all called conference marking.
Yes.
Only he will not mark. So that idea is mathematics. 0.1 and 10%. It's the same thing. It's not that when we are teaching adults like you, we want to do everything as if you are still a child. That's how it looks like. But we are just telling you that 0.1 and 10% is still the same thing. Even if you check, Even if you check Professor Lowen's book, which is, we can look at it as one of the oldest, it's still in his book, you see 0 point. You may not even see 10%. So the choice is yours. So that should not be an argument. What's the answer? 0 point what? And the other one is 0 point what? 0 point. Okay. So what the question is simply saying is that we have gotten this as 0.10. This one is 0.48 or 3, whichever one. 0.5. 9K. How about that? This is 8, 9. Divided by 15. Okay, 0.5. Okay, good. Now, the question is asking which of these projects is. So what's the answer? Project B. You are correct. So the one that has the highest, even if it's coefficient of error or standard deviation, is always the riskier compared to. So if we are going to select project, we want to select because this one is not. This one is still fair. This one is risky compared to what is more risky. So this one we select this if we are going to choose a project. But this is a project that is what. To answer to that question, project B is risky when compared to project 1. Is that central? It all depends, because sometimes a project is if it's not managed very well, you have it. And if it's managed properly, even this one will also be better. It all depends on the but yes, now out of these two now, what advice you can be which one to take? Which one will you take? So we take this. But this one we have more costs, there will be more losses for this. Or this one contains danger compared to this. Is that okay? So for this one is there according to the solution to the question. When you want to choose projects, you choose project. Is it clear? So that is question 1, and then 2. We'll take the last one, which will take us, which will be lengthy, which has more formula, as the case will be. And with that, we will conclude probability-based lecture. Some other time, we'll be talking about the other method. Let's see how to sum. Okay, this one has more than 1 year project. That's up to 3 years. Sometime in examination, you can also see 4 years. But most of the questions they said is that they don't go more than 3 years. So we have this. Year 1.
Excuse me, sir.
Yes.
Can you please adjust the phone so that it's centralized? It's kind of tilted to the right.
Which one? Okay.
Thank you. It's fine.
Welcome. Yes. Okay, that's the question. Already we have idea. Okay. The way we have done before, sort out this 1, 2, 1 after the other like that. So this one we see one cash flow of year 1. So we have cash flow of year 2, cash flow of year 3. This probability of year 1. So here is going to be 25, 1.2, 1.5, 1.3, 6,000, 1 point. Go ahead. So here will be C1 times P1. We have C1 minus expected value. We have C1 minus expected value cos squared multiplied by P1. As usual, 25 times 6. 500. All right. 500. S. 1350. S. 3000. Expected value of project in year 1. Add this together. I'll give us 4850. This one has gone. These are not a problem. Next thing is negation. This is our negation. Negation. 5 minus expected value is minus 2,350. S minus again.
Minus 350.
Minus 350. The other one is plus. I hope you are following. I hope you are not just an observer. I hope you are participating. One. Minus K.
No, 1,000.
1,000. Like this, Abby. Good. The next thing is to square this, multiply by the probability. Square this as we did before. Oh, yeah. Make sure you are pressing this calculator.
1104.
This one is 110500. S. 3670. I mean.
750.
Okay, 750. S.
661,250.
661,250. So automatically, year 1 result, and everything together.
180,250.
180,250. Have it. We have just finished year 1. And what happened in year 1 is what will happen in year 1. Will also happen in year 1. I don't think there's much stress. Just the formula you need to remember now. Those of us online, any questions? That's why there's a risk about today. So now we're squaring it. Another question? I will have done yes. I want to do it. Just repeat what I did in your one. Are they trying? Yeah, too. You can't be there with doing everything. After all, you're the one that collected one. You can collect one. Okay, right. Everyone is trying. Make sure you are trying to put this on the body. And it's not. Make sure you are to work in participate. Are you back? Are we all working? Look fast so that we can conclude this. Because we have shown you as why you should be able to do 2 and do 3 so that I conclude the matter. Remember that this one is EB1, this EB1, the one you are doing is EB2, and the variance of 2. This square on top of that is sequence of variance. So when you now find the square, it becomes that sequence. Make sure you are putting 1. EP. One is EP1. One is 1. So, make sure you are there, except those of us that are just coming. By the time you use your calculator, let's ask you guys your calculator, and you press minus with the number you square, and the minus is there. Ignore. Because minus times minus will always be plus. Because if you don't press it, minus is a case. Don't press your minus and go ahead. Mathematics will not change, irrespective of who is what you are using and who is talking. Yes, so that's the fact. Math is a universal language. Awesome. Are you there? We have done 2, 3, and 3 also. Okay. We have 2. EB is what? 6, 4.
Yes,
EB is 6, 4, 5, 7. I always be like that. I can play for I am. Which one? Let's get it simple. One, 3, 7, 2, 5. Good. 7, 9. Good. So, year 1, we all have gotten the values. We have not gotten the value. Make sure you get the value because there's no time. Already going out very soon.
So what do you celebration of this
So yes, when you square this like this, give me 765. Now it's 60. So 551 command. Okay. Well, okay, yes. Let's mind it doesn't matter. Correct. Well, through now, what I will just do now is to write out the things. What people got, you have not gotten yours, you have to work towards it. This is year 1 or year 2. EB2 is what?
EB2 is
6, 4. And then this one is 1, 3, 7, 2, 500. For year 3, year 3 is what? Is that? And the other one is the same, I mean. Is it the same? Right here. same? When you add 760,500 plus 60,750 plus 5,1, because the value is something with the upper one. How far is it clear? Is it clear? So if you have followed this process, you should get this in year 2. Year 2. Follow the process in year 3, you should have this and this. If you have not gotten it, that means you not do a good job. Try again. Are we on there now? Remember that this hello, this is our 12%. 12%. It's still the same. Okay, it's risk-free already. We always use risk-free. I'll show you a question in the past. Can get your 3 rates. I'll tell you what. But you always risk what? Are we there? A part of the question, expected value of MPV. What is our E1? 4 over. I hope it's 12% plus 6450 rest over. That's year 2 of it. Plus 750 over 1.12 minus 1. Any questions? You know, the last time we just did 1. You only this we did. And subtracted. All these we are not there because there's no year 2 and 3. It's only 1 year project. So it's only this we add and not 0. But now we have more than 2 projects. So the first over discount factor plus the second over discount factor plus the third over discount factor. Is it clear? What we did before is the same. Then we have 4 years and we are adding. Any questions? Calculator can do a very good job. This over this. The calculator has a fraction. Am I correct? Hello? Those of you using calculator, you have something like this in your calculator. Or some of us, your calculator has this. Which one your calculator gets? If you are using Casio, if you want, you have this. If you are using the old one, you have this. So what you can do for yourself in examination, not to waste time, just press your calculator. 4850. You press this. Scroll down and put 1.1. Plus, you press this. You press that symbol. 1.1 raised to power 2. Plus, you press this 1.1 raised to power 3. Or, if you don't like it like that, you can start 1.12 raised to power minus 1 times 6 plus 1.12 raised to power minus 2 times 6 plus 1.12 raised to power minus 1 minus 3 times 6. Any method you have adopted, you get the answer. Or by the time I don't like that method, you take it 1 by 1, but that one can work. This over this, you get that. This over this, you get that. This over this. Now add together. All we know, we all get the same answer. And our mind will not change. The same thing, that's what I'm saying. Just a one thing. But if you take your time, get this, get this, get this. And add it together and subtract. The same thing you will get. Yes. Everything. Have you subtracted the CO? Did you subtract CO? Okay. This is what? 15. Okay, yeah. A moment. So our result is 15 was your quarter time. 15. 130.91. Minus 10, 900. Minus 10, 900, I mean. So then have 4,230.91K. Is it positive or negative? That means the project should be accepted. I mean, That one has gone. The next thing about the question is I should find, what is it? Standard what? Deviation. That is okay. See? Is that standard deviation? Is equal to the square root of summation C all over 1 plus R raised to power 2t. T starting from 1 to n. T is 19 at time 1, time 2, time 3. But don't forget that the formula has 2. Don't forget that. Remember, this is variance, Abi. All the variances of year 1, year 2, year 3, with our rate, which is 12%. So we're having here, what's the first one? 1 what? Huh? Are you sure? 1 8. The day here, we'll never forget. I don't feel like it. 1,8,1,802 500 over 1.1. 2 times 1, now we do a rate. Year 1 now, year 1, put 1 here. 2 times 1 is not 2. Plus the second one, what was 137 to 500 over year 2, Abi. That will be 1.1 raised to power what? Plus the last one, 1372500 over 1.12, 2 times 3. Remember, all of them is carrying what? Square. And that's, so it's not clear. We don't mind.
Because you have to start from 2.
We didn't start from 2. Formula get 280.
Why don't you have?
Formula has 2t. You can't argue formula now. Those that came before us say this is the formula.
Formula
for final standard deviation. Sure. Of the project.
Can't you just do it 1 by 1 like we did initial?
Which one is the 1 by 1? Now 1 by 1 will go now. 1 by 1. 1 by 1. So that for example was 1 year now, Abi. It wasn't a problem. 1 year wasn't a problem. We just do standard deviation. So this is if you do separate, same thing now, but this is the formula for all. It's a project. We are running it together. If you want to do separately, no problem. But this is a project of year 1, year 2, and 3. We are running it together. After all, we did this one together. Did we do it separately? Stop now. Did we do this separately?
No.
Why are we going to do this separately? When the project is 1, 2, 3, probably 4. You're running like this is the formula to use. You must get yourself acquainted with this one. There's also we can do about it. The formula has 2t. Don't forget. Year 1. This is year 1 result we got, Abi. All over 1.12. 2 times 1. 2 times 2. 2 times year 3. As when you get to year 4, to be 2 times 4, 8. Year 5, year 6, and so on. When it has to do with more than one project. The first one we did was 1, and that was why I took time to start with 1 project before we now graduated to 3 projects and more. Is it clear? There's still multiple projects, there's no more than 1. You do this. But for single project is what we did. We don't find standard deviation, the square root of the only one variance we have in the question. That one was quite different. But this one is a multiple project, and we have to go this way. Remember, wait, let me explain something. In that one I did was standard deviation of that cash flow, which is that question I load. This one is standard deviation of the whole project, which is multiple. So and they cannot even give you in exam. They can't give you that single project. It's too small. That could be objective question they said. But for theory, this is what you see. Somebody turn to your past question, 2019, 2020. Open the next page. Who is there? Past question. Anybody with one here? So that we can show you what we are doing. Maybe not be like say we too much. Huh? I have 2019, 2020. Go to the next page. B. Have you seen B? Can you solve it? You will solve it. Now that you have seen. So anybody look at it very well. The person says that's what I want to explain. He said treasury B is currently 10%. The first cost of capital is 18%. Kola Wale, the owner of the business, currently borrows at 21%. There is 10%, there is 18%, there is 21%. What you are going to use is 10%, which is treasury what? Bill. Treasury bill is what we call risk-free rates. And that's what you are going to use, and that's what is always used on the board. Those other three ratios are just a way of distracting those who don't know what they are. 20, yes? That's the examination question. What you have to use is risk-free ratio. And that's what it's on the board. It's all risk-free, have it? So risk-free is what we use in calculating this. We don't use cost of capital. We use risk-free. And how much the guy borrows money, it doesn't concern us now. All I want is the owner of the business, that he borrows money at 21% somewhere. Has all to do with the project. What's important is the risk-free ratio. And that's what we use. And that's what you always use. Are you with the question? It's on 2019, 2020. Are you there? Help us snap and send to them. Just this one, so that they can see what we are saying, that we have done it. Please snap. Can you do it? Can you not do this? That means we have sorted it out. Look at the question you said. Can you do it now? You can do it at home. The formula. This one. You know this is how I'm writing. This is variance. Variance at time what? 1. That's the T at time 1. Time 2. Time 3. Settle. So this is time 1, which is this. This variance at time 1. Over 1 plus R, right? R is our risk-free rate, discounting factor, which is 12%. 0.12 plus 1, that is 1.12. And this is T at time 1, year 1. 2 times 1, 2 times 2, 2 times 3. And it continues, assuming it gets to year 4 or 5. But most year examination, they give 3 that have not seen point in their past question. But that means you can solve that yourself, Abi. So that means that part of probability base has been done. That means everybody can solve that one. The first question, as normal as you can't solve it, let us know now. And you can't solve it, let know. Because you have no reason not to get the answer. Those of us online, can you handle the question? So I hope somebody must have been doing something for us here. This over this, plus this over this. What do you have? 3 million. Let me check. Say it's 3 million.
300.
Okay, 3004. 511. I mean?
41. 541.
Okay, 541.7. Okay, find the square root of this. This 0.4 or 36, anyone. So that's our standard one. Standard deviation of the project. C part of the problem, coefficient of variance. And that formula is standard what? Standard deviation of what? Standard deviation. All over expected value. Expected value of the what? Project. Or of the MPV, that's what we need now. Because the expected value was scattered, okay? We have the 1, we have the 2, we have the 3. As means only a 1 we had, just have to use that one. But now we have so we have here standard deviation 1733.4. This one 43123. Somebody press calculator. 4 point what? 4 point what? Nobody said it. 4.4096. Are you sure? 40. Okay. 409 what? Something like that. 96 again. 97. Okay, approximately 97, which I told you is something as 40.97%. Whether this or this, you are still in order. The choice is yours.
No, in the previous question,
Yes.
expected value.
Your is expected.
So in this way, there are two expected values.
Maybe it's like that's it. Doesn't if you have more than one expected value, we would have got this one with this other. Remember, we calculated expected value for all of them, I think. So we now have this. This is what we're going to use. Because we have standard deviation of the whole project, all over expected value of the whole project. What if it's just one? We only have one expected value. Any questions? We all can handle that. Remember, in this question, we talk about probability-based method. In this method, we have seen how to handle expected value, standard deviation, coefficient of what? Variance. Maybe next time when we go surface, look at the other part and see what we can do. For any question? Any other question? Who is not clear? Those of us online, any questions? Those of us sitting down here.